Somewhere in the constellation of Sagitta, the arrow, a faint point of light, is defying the rules of stellar evolution. To the naked eye, Sagitta is one of the smallest and most overlooked constellations in the night sky, a tiny collection of dim stars, often lost in the vast sea of darkness between the brighter constellations of Aquila and Cygnus. But hidden within this modest arrow lies a target that astronomers are watching with increasing anxiety. This system, known as V Sagittae, is currently blinking a frantic warning code. It is one of the most violent, unstable, and rapidly changing objects in our galaxy. For decades, this binary system was dismissed as just another curiosity, a strange, cataclysmic variable star that didn't quite fit the standard mathematical models. It was a puzzle piece that refused to snap into place. But a new, exhaustive study has fundamentally changed our understanding of what lies there. We now know that this isn't just a star flickering benignly in the dark. It is a cosmic engine accelerating toward a catastrophic failure. The latest data tells us that V Sagittae is spiraling toward a violent destiny much faster than anyone anticipated. It is preparing for an eruption that will eventually transform it from an invisible speck into the brightest star in the Milky Way, a beacon of light so intense that it could rival Sirius and perhaps even be visible while the sun is up. This is the story of a stellar relationship turned toxic. It is a story of cannibalism, unstable physics, and a countdown clock that is ticking louder every single day. Today, we are going to break down exactly what astronomers have found, why this system is unique among billions of others, and what we can expect when the fuse finally burns down. To understand why the recent updates are so shocking, we first have to understand why V Sagittae has baffled scientists for so long. This system belongs to a very exclusive club of objects known as cataclysmic variables. In a standard cataclysmic variable system, you have a burnt-out white dwarf star, the dense, dead core of a sun-like star, orbiting closely with a normal companion star. The white dwarf's immense gravity strips gas off the companion. This gas spirals inward, gets incredibly hot, and occasionally flares up. Usually, this process is messy but somewhat predictable. But V Sagittae has always been the problem child of this group. It is roughly 100 times more luminous than a standard variable system should be. Furthermore, it blasts out a specific, strange type of high-energy radiation known as super soft X-rays. This specific X-ray signature is the key to the mystery. In astrophysics, X-rays usually come from violent collisions or magnetic fields. But super soft X-rays are different. They are thermal. They indicate that something is incredibly hot, but radiating smoothly, like a hot iron poker, rather than snapping and popping like a firecracker. For years, the scientific community was split into two camps trying to explain this anomaly. One camp believed this was a standard white dwarf pushing the limits of physics, eating so much material that the gas wasn't just falling onto the surface, but was actually detonating in a continuous nuclear explosion. The other camp argued that a white dwarf couldn't possibly sustain this kind of output without blowing itself apart. They proposed that we were actually looking at two massive living stars, O-type or B-type giants, hidden behind a veil of gas, mimicking the signal of a dying star. Without better data, neither side could claim victory. The system is so erratic, flashing and dimming so unpredictably, that getting a clear measurement was like trying to read a newspaper in a strobe light during a hurricane. That is, until the most recent observational campaign changed everything. To finally solve the puzzle, a team of researchers turned to one of the most powerful eyes on Earth, the Very Large Telescope, or VLT, located in the Chilean Atacama Desert. They utilized an instrument called the X-shooter. Most spectrographs can only look at a small slice of the light spectrum at one time. If you want to see ultraviolet, you look for 10 minutes. If you want infrared, you switch filters and look for another 10. But for a star like V Sagittae, which flickers and changes every few minutes, that approach fails. The X-shooter is unique because it can capture a massive range of light wavelengths simultaneously, from ultraviolet all the way to infrared in a single shot. This wasn't just a quick snapshot. The astronomers committed to a marathon observation run. They monitored V Sagittae continuously for over 120 nights. This duration was critical. By watching the star complete its orbit over and over again for months, they could build a complete three-dimensional map of the gas moving within the system. They used a technique called Doppler tomography. Think of this like a medical CT scan, but for stars. By measuring how the light shifts towards blue, moving toward us, or red, moving away, as the gas spins and swirls, they could reconstruct the geometry of the system. They were essentially mapping the song of the star to visualize its shape. What they found in this 120-day movie was startling. The data effectively killed the massive star theory. The spectral fingerprints, specifically the presence of ionized helium and nitrogen, confirmed that the heart of this system is indeed a white dwarf. But it is a white dwarf living on the absolute edge of stability. The observations revealed a chaotic, turbulent flow of matter that isn't just streaming from one star to the other, it is practically flooding the system. Let's break down the physical reality of what the VLT actually saw. We have two stars locked in a tight, death-defying orbit. For a long time, we assumed this was a David and Goliath situation, a massive, ordinary star dumping material onto a tiny, lightweight white dwarf. The new calculations have flipped this picture. We now know the stars are essentially twins in terms of weight. Both the donor star and the white dwarf are sitting at roughly 1 solar mass, about the weight of our own sun. This mass equality is crucial to understanding the violence of the system. In orbital mechanics, gravity dictates the size of the Roche lobe, the teardrop-shaped region of influence around a star. When a donor star is heavier than the receiver, mass transfer usually stabilizes the orbit, pushing the stars slightly apart. But in V Sagittae, the donor is massive, and as it loses weight to the white dwarf, the gravity holding the system together shifts in a catastrophic way. The donor star physically expands, while its Roche lobe shrinks. The result is that the donor star is being stripped apart. The data shows a thick, choking stream of stellar material slamming into the white dwarf. This isn't a gentle trickle, it's a fire hose. The white dwarf is enveloped in an accretion disk, a flat, spinning pancake of superheated gas that is screaming around the star at thousands of kilometers per second. But the most exciting finding from the X-shooter data was the confirmation of a circumbinary disk. The researchers found that the white dwarf is so overwhelmed by the incoming fuel that it can't eat it all. It is spitting the excess back out. This material is forming a massive, hazy ring that encircles both stars. This discovery is the smoking gun for a messy, chaotic system. As the binary hemorrhages gas into deep space, that expelled material acts like a cosmic brake. It steals angular momentum from the stars, draining their orbital energy and forcing them to spiral inward ever faster. Why does this guarantee an explosion? The clue lies in that super soft X-ray glow. It confirms the white dwarf is currently acting like a continuous nuclear reactor, fusing hydrogen the moment it hits the surface. But V Sagittae is pushing this process beyond its breaking point. Recent data reveals erratic, high-speed plasma winds, a clear sign that this steady burn is failing. As the fuel layer grows too thick and hot, it will trigger a runaway reaction, a massive nova event. Astronomers believe this won't happen centuries from now, but potentially within decades. We could see it in our lifetimes, a new star appearing in the sky, rivaling the brightest planets before fading back into the dark. Yet, the nova is merely the opening act. The true danger lies in the system's trajectory. The current 12-hour orbit is shrinking rapidly. As the expelled gas drags the stars closer, mass transfer accelerates, which creates even more drag, a runaway feedback loop. Inevitably, the stars will bridge the gap. The donor star will be ripped apart, leading to a catastrophic final merger. This impending merger is what generates the real excitement. We aren't just talking about a standard explosion, but a merger-driven event releasing a titanic amount of energy. Current models predict that when this peaks, likely later this century, V Sagittae will become the most luminous point source in our galaxy. It likely won't be a typical supernova, but rather a luminous red nova on a massive scale. Imagine the star expanding rapidly, glowing with a fierce, deep red intensity as it engulfs the inner orbits of its own system. To put that in perspective, it would outshine every star in the night sky, casting shadows on the ground. At its absolute peak, it could even be visible as a sharp pinprick of light against the blue backdrop of the daytime sky, a ghost star hanging above us. Why does this matter? Because V Sagittae is a Rosetta Stone for astrophysics. While we see the colorful aftermath of explosions all over the universe, we rarely get to study the before picture. With V Sagittae, we are watching the prequel. By observing this pre-explosion phase, scientists can finally calibrate their models of star death. It helps answer critical questions about where heavy elements come from and how the sources of gravitational waves, detected by instruments like LIGO, are actually formed. By watching this system, we are witnessing the prelude to a gravitational wave event, giving us clues on how to hunt for others in the dark. V Sagittae is no longer just a faint dot in the Arrow constellation. It is a laboratory of extreme physics sitting in our galactic backyard. The new observations have stripped away the mystery to reveal a cannibal star gorging itself in a fatal, spiraling dance. Undeniable evidence of a system living on borrowed time. Whether it manifests as a nova in the next 20 years or a great merger at the end of the century, V Sagittae is waking up. The clock is ticking. For now, it remains a quiet flicker in the night, but soon it will become a light we cannot ignore.